Hi everyone, and welcome to the start of our discussion on applied econometrics. So, this will be video one of quite a long series all about applied econometrics. So, we're going to go through what econometrics is in general, go through the basic classical linear regression model, discussing its assumptions, its limitations, the things that it can address, and we're going to go through a couple of other models, such as binary response models and panel data models, to round out the term. We're going to do this all in this series. So I hope you stay around and learn as we go. So let's start with this very first video, which is just going to give a brief overview of what econometrics is and what are the goals of econometrics and what's the econometric procedure. So what is econometrics? Well, econometrics is essentially based upon the development and the use of statistical or empirical and mathematical methods in analyzing economic data. So essentially, we use the concepts that we had learned in statistics and math to analyze real world data, economic data, in order to try and estimate or analyze and validate economic relationships, try to look for them and see if they exist. We also want to test existing economic theories and evaluate and implement economic policies. Over the years, econometrics has become a very indispensable tool in an economist's toolkit in trying to defend his or her viewpoint or in trying to see which alternative may seem best. So, as I said to an economist, econometrics has become quite invaluable in our analysis of the world. So, of course, the world operates around many intricate relationships between various quantities and variables. And what we want to do using econometrics is to try and understand these relationships, try to model these relationships such that we could shed light on some issues and some problems that we can potentially solve by implementing the right policies. So it's analyzing this current phenomena and potentially trying to forecast this future social composition by which we can use these tools to sort of make a better inference about how we should be going about things, right? Now, there are generally four econometric goals that we will discuss in our class. The very first econometric goal is just basically the analysis of economic theories, right? So it's analyzing economic theories. So when we analyze economic theories, we can get a clearer picture of what is going on in a particular time period. And what would happen is it may be that our analysis may persuade us to believe in one direction or thought over another based on what empirical strategy we use. So, of course, in econometrics, we have a lot of competing models, and sometimes competing models might give you different answers. And all in all of these models try and analyze or try and pinpoint some economic theory, try to tell their side of the story. And it's our belief that we should be discerning and trying to pick which one we think is best, given the sets of limitations and advantages and disadvantages that we know about each and every model. So we want to use these econometric models to get a better sense of what the world is, and it may be leading us to a particular viewpoint. So that's one thing. Another key econometric goal is to inform policy. So economists nowadays are your main policymakers, and we want to know what policies work such that the future of society can be better off. That's our goal. And as I said, our primary goal, one of the primary goals of being an economist, is to undertake and to build and mold a very sound economic policy or sound economic policies for the betterment of society. Now, while forming a singular policy is great, it is important that when we build policies, it be structurally sound and backed up by ample empirical findings. So one way for us to validate or to persuade people to take our policies or for us to be able to implement our policies is to tell them, hey, based on this empirical strategy, we found that this could be effective and this is the best alternative given the things that we could think of. And that's one way for us to sort of inform our policy, finding the right policy for the moment. And moreover, even after a policy has been implemented, we can still use econometrics to evaluate the impact of the policy. Really ask a question: was it effective, or could I have done something better, or could we have just gone with another alternative? Did the policy work and achieve its intended outcome? We also use econometrics to try and discern that particular thought. So the first two goals are analyzing economic theories and informing policy. The third one is on validating or opposing economic theories. So economics as a discipline has always been accustomed to change. We have many volumes and many editions of our textbooks, and that's because the world is dynamic. Theories yesterday do not work often today and are constantly revised as we learn more and more about the world. So uh, our understanding and our conception of the world changes as the world progresses on. Hence, we need to continuously validate or sometimes oppose economic theories based on how the world is going. So we use econometrics as a tool for us to be able to validate or oftentimes or sometimes oppose the economic theories that we've had and replace them with theories that are more akin for the time or that are more universal as compared to the theories that we may have had or have now. So that's another function or a goal of econometrics. The last one, at least in our class, will be to forecast quantities and phenomena. And I think it's the most well. If you ask a person who isn't an economist, what's the main function of econometrics, or an economist for that matter, likely they tell you, well, a lot of economists are forecasters, and that's true. One of the main goals of econometrics is to be able to forecast quantities and phenomena. Essentially, we want to have a better grasp of what the future could entail. And what we do is we take the results that we have in light of the past and in the present to be able to forecast the future, such that we can be better prepared for the challenges that we could face in the future. And that's one function of econometrics, to try and shield from the risks, the uncertainty, and the potential externalities or pitfalls we could experience. So it's a very powerful tool in this regard, that we can forecast quantities such that our policy or our decision may be better informed, whether it's through money making or through other means for policy. That is a main goal of econometrics. So those were the four general econometric goals. So let's now move on to the econometric procedure. So how do we conduct econometrics? Well, oftentimes it's similar to how we do generally a paper or a research. We start with observing a phenomena. So we start by, okay, saying, what do I see in the world around me? What is something I want to observe? What is something I want to sort of find a deeper meaning into, try and that's something pertinent, at least to me, something that I could work on, and I could try and see, okay, this may lead somewhere. I could maybe use this to inform things. Okay, so we start by looking at an economic phenomena, things like production, consumption, growth. These are phenomena that we would like to understand. Unemployment, poverty, these are conditions that, these are problems in some cases, and we'd like to solve them. And part of that is through using this procedure. Then when we pinpoint a particular phenomena, we'd like to model that phenomena. And as we all know, the way that we model most of the things in economics is to use mathematics to do that. We'd like to create mathematical models such that we close our logic under a very logical language. We close our theory on a logical language. So we'd like to model, okay, what are these things? So we may, for example, in the case of production, we have like a production function, right? For the case of like consumption, a consumption decision may be based on some autonomous consumption plus some with respect to disposable income and sort of those things. So these things are models that correspond to sort of real world things that we sort of expect. Then we generate a statistical model from that mathematical model that we can incorporate real world data. Then after that, we generate our main econometric model, which is essentially what particular approach or methodology do we use to analyze this real world data, which we modeled mathematically and statistically. Then, after we model it, this is where your betas come in and your epsilons, right? After we model that, we'd like to see, okay, is what we modeled statistically significant? Can I trust it to some extent? Is it prone to biases that I may have not realized initially? And that's where statistical testing comes in. We don't just accept the results of a mathematical or an empirical exercise like other disciplines may. We would like to test, okay, is the result that I have valid? Is it useful? Does it have empirical robustness? Is it empirically robust rather? Can I trust it? That's something that's important. And if we find that these results are past our diagnostics and our tests, then we try to use these results to meet the econometric goals. And that's ultimately what we want. We want to use the results of our model to analyze economic theories, inform our policy decisions, validate or oppose existing economic theories, and to forecast future quantities. So that's a brief overview of the econometric procedure. So let's try and use an example for it. So for example, say we have production and you observe production as our phenomena. So the first step is phenomena. So say we look at the ambit of production. And generally speaking, we tend to measure production, at least in terms of a real world data point, as a country's gross domestic product. Now, we know that by theory, production is usually some function of the amount of labor and capital. So it's amount of like an industry. One of the approaches to count GDP is through an industrial origin approach, and in normal and by usual, these industries employ capital and employ labor. So it's some function of these two things. Now, we can start building a mathematical model out of these things. So we start by identifying, okay, what's a typical mathematical construct of production? And we know that actually, when we discussed it before in macroeconomics, we generally start with a production function. And there are many forms of production functions, many types of production functions. But for simplicity, let's assume a very simple production function wherein you have production, which is Q, as some function of labor and capital. So Q as some function of labor and capital. So you have that one there, right? So mathematically, your model may be expressed as this. Now, a key important thing that you would want to know about the phenomenon of production is analyzing these marginal contributions. And these marginal contributions lie at the heart of econometrics. What do I mean by this? Well, when you're analyzing production, you want to analyze, okay, what contributes to production? What are the things that I should be considering? What are the relation? What production has a relationship with what variables? And in here, we pegged it at labor and capital. And labor and capital have marginal returns to the production. So if you increase labor by, say, a unit, how much would production increase? If I increase capital by some amount, how much would the production increase, and so on. So you have here these parameters alpha and beta in a standard. Say, for example, our production function was a standard Cobb-Douglas production function. We have alpha and beta, which are parameters that we have, and we'd like to estimate, okay, what are the returns to labor and what are the returns to capital? So we could sort of understand the phenomenon of production better. Which contributes more to production? Is it labor? Is it capital? Do they reach a limit wherein they start to become unproductive, and so on? So these are things we'd like to know about this phenomenon of production. Now, apart from the marginal contribution, the production function also tells us, of course, the marginal contribution of each unit of labor and capital. So, for example, you have your production function, which is Q, which is a function of capital and labor. If you take the derivative of that function, the partial derivative with respect to K, you get your marginal product of capital. If you take the derivative with respect to L, you get your marginal product of labor. And that's the additional output you get from increasing either labor or capital, holding the other input constant. And those are important things to know about in terms of underlying economic relationships. So these are the things we're looking for. What are these marginal contributions and how do I make sense of these? Now, a statistical model is essentially akin to a mathematical model, but focuses on the marginal more often than not, right? So for example, let's take the natural log of both sides of the production function. Say you had this production function Q is equal to L alpha K beta. So one way for you to do that, at least try and make it easier to analyze using real world data, is if you take the natural log of both sides. So essentially it's like a growth term with your Q, and you have alpha ln L plus beta ln K. Now, this note is now a linear model. This is now a linear model wherein you have parameters here, alpha and beta, representing what uh, labor and capital give towards output in a linear manner. And this may be readily estimated by one of the models that we will start to discuss in econometrics. So essentially, if I take the derivative of this, right, if say we have this function, I take the derivative of that with respect to the two inputs, I get alpha and I also get beta. And these are our marginal contributions that we keep on talking about earlier, right? So these contributions are important in analyzing in analyzing the phenomenon of production. What is alpha? What is beta? Which is higher? And that informs generally a lot about the policy that we could potentially get out of that. So now that we have both a mathematical and statistical underpinning, we can now create the main econometric model. Now, creating an econometric model involves getting real world data. So we get data for production, we get data for labor, we get data for capital. So production, oftentimes you could put it as GDP. Maybe labor is like your employment rate or your number of hours worked on average. Then you have capital, which may be gross capital formation. These are real world variables that represent these variables, which we constructed based on our economic theory. So this is the theory meeting real world data. And we're going to regress that and see what these relationships are on a very empirical real world basis. Okay, so we use these data to be able to build our econometric model. And of course, we'll go to it in further detail in another video. But for now, the econometric model can be formulated as this model below. GDP, or production, is explained by labor and by capital. Labor has a contribution, beta 1, and capital has a contribution, beta 2. Essentially, you can think of beta 1 as the alpha we've had earlier, and you can think of beta 2 as the beta we've had earlier. Your returns to capital and your returns to labor, right? So here we express production as the dependent variable, the variable we'd like to explain the variation of, and your independent variables are your capital and your labor. And essentially, everything that wasn't explained, so of course, production is explained by a lot of things, but in here we zeroed it down to labor and capital. Anything that labor and capital does not explain about production, we lump it into this term, which is U sub I. And for now, we'll just leave it as U sub I. But of course, we will formalize this in the next few videos. So it corresponds to some error that we cannot explain about production, or at least the independent variables that we have in the model cannot explain about production. So once we regress, i.e. find the values of beta naught, beta 1, and beta 2, we need to conduct formal statistical testing. This is the part where I'm saying that, okay, we found the model for it, we regress the model, can I trust the model? So that's where these statistical inference and these tests are involved. So typically we do tests of individual significance, determining whether labor individually or capital individually is significant. Then we do collective significance, whether the model as a whole is good. We do goodness of fit measures, whether the fit of the independent variables relative to how it explains the variance of the dependent variable. Is it a good fit? We also look at a couple of other measures by which we judge a model. Does it suffer from a couple of biases that are common when running certain models, and so on? So suppose we pass all of these tests, these formal empirical tests, then we go out of our way and use the results that we found out from this model to meet the econometric goals. We want to inform policy, analyze the existing economic data. We either validate or oppose a certain economic theory with it, and we use it to forecast future unknowns. So that's a brief introduction of how econometrics is done, what it is intuitively. And in the next few videos, we're going to start our discussion formally with a classical linear regression model. So thank you for your attention, and I'll see you in the next video. Thank you very much.